Welcome to the second video in the systems of equations. Remember last time we talked about graphical ways of solving systems of equations. Today we're going to start our first non-graphical method. So remember the group work that we wound up doing involved us graphing a couple of lines and seeing where they met. So if I were to plot a couple of points, and draw the line that goes through them, and then plot another couple of points, and draw the line that goes through them, we can see that there should be a way to figure out where they meet. Our graphing skills might not always be perfect, and so we probably want a way to do it that we're absolutely certain will work. What we did last time was we took and graphed a couple of equations like y equals x plus 2 and y equals 2x minus 3. So we graphed those, and in the group work what we were doing was we were taking and setting the right sides of these two equations equal to each other. And if we did a little bit of work, move things to one side, move things to the other side, we found that this matched what we were getting from the graph. If we graphed y equals x plus 2 and y equals 2x minus 3, we saw that the point that they met at was actually had x coordinate 5. And so this gave us hope that maybe there was another way of doing this. When we took this number, x equals 5, and plugged it back into one of the original equations, and got 7, we noticed that it exactly matched where we thought they met, 5, 7. So what's going on here, and why does this work? And what are we going to call this? Our first method is going to be called substitution. And the way substitution works is it says if you have two things which are equal, you can replace one with the other. You kind of want to think of this as the math equivalent of synonyms. Right? So what we said is if you have A equal to B, then A and B are, I'm going to write sideways here, interchangeable. Okay, so let's see why this is working for us. Let me go ahead and put up here x equals 2 plus y, and y equals 2x minus 1. So this equation is in terms of x, and this equation is in terms of y. We can see that the first equation tells us, well, that whenever we see x, we can replace it with 2 plus y. And whenever we see y, because of the second equation, we can replace it with 2x minus 1. Replacement's nice because it removes a variable. So if I take y equals 2x minus 1 and I replace the x with 2 plus y, well, we need to be careful. Remember that 2 is multiplying all of x there. So we get 2 times 2 plus y minus 1. So we're going to have to distribute here. And what are we going to get? We're going to get y equals 4 plus 2y minus 1. If we combine terms, we get y equals 3 plus 2y. Let's move the 3 to the other side. and we get y minus 3 equals 2y, and move this y to the other side, and we get negative 3 equals y. Let's copy back our original equations. X equals 2 plus y, and y equals 2x minus 1. So I got y equals negative 3. Y equals negative 3. You can kind of think of this also as a replacement. Y is now a synonym for negative 3. So any y I see, I can replace with negative 3. So for example, in the first equation, I can write x equals 2 plus negative 3. 2 take away negative 3 is negative 1, and so I get x equals negative 1. Well, what would happen in the second equation if I replaced y with negative 3? I would get negative 3 equals 2x minus 1. Let's move the 1 over. I would get 2x equals negative 2. And if I divide both sides by 2, I'll see that x still equals negative 1. Well, in both cases I got x equals negative 1 and y equals negative 3. And so we should see that negative 1, negative 3 is our common solution. Let's check it just to be precise. Remember, x equals 2 plus y, and negative 1 does equal 2 plus negative 3. We have y equals 2x minus 1. And negative 3 does equal 2 times negative 1 minus 1, because that's negative 2 minus 1, which is definitely negative 3. Let's try another one. Let's take y equals x plus 4, and y equals 3x plus 2. Where would these meet? Well, the way we have to work this is we have to do a substitution. This equation allows us to replace y with x plus 4. This equation allows us to replace y with 3x plus 2. Let's go ahead and replace y with 3x plus 2. So when we replace, it's incredibly important that we choose the equation that's letting us replace, and use it to do a replacement in the other equation. You would never use the replacement equation in the replacement equation. You're always going to use one to replace the other. So I'm going to replace y with 3x plus 2. That's going to give me 3x plus 2 equals x plus 4. Let's go ahead and solve. Get x to the same side. 2x plus 2 equals 4. Move the 2. We get 2x equals 2, which is x equals 1. Now that we've gone ahead and found one of the two numbers, we have to use replacement one more time and find the other. So I'm going to replace x with 1. We can choose either of the two equations. You see that y equals 1 plus 4 gives us y equals 5, and y equals 3 times 1 plus 2 also gives us y equals 5. So what is our answer? Our answer is 1, 5. This is nice because it allows us to get away without having to graph. Now, it's not true that all the time you'll be able to do replacement right away. If I write 2x plus y equals 3, and x plus 2y equals 3, well, it's not going to be obvious what we could use to replace. We don't have x equals or y equals, but it's always possible to take one of the two and change it. I can change x plus 2y equals 3 into x equals negative 2y plus 3 by subtracting 2y from both sides. So I've done that. I now have a new equation. This is my replacement. I'm going to use it to replace x here. So what do I get? I get 2 times negative 2y plus 3 plus y equals 3. That's negative 4y plus 6 plus y equals 3. Move the 6, and on one side we get negative 3, and negative 4y plus y is negative 3y. So when we divide both sides by negative 3, we get that y equals positive 1. Well, let's take 2x plus y equals 3 and y equals 1 to find x. 2x plus 1 equals 3. Move my 1. I get 2x equals 2. Divide by 2. And I get x equals 1. Now we know this is going to work in 2x plus y equals 3 because that's where we just got it from. But let's check in x plus 2y equals 3. If I write x plus 2y equals 3, and I substitute my y equals 1 and my x equals 1, then I get 1 plus 2 times 1 is 3, which is definitely true. So you can see that we can substitute. The idea behind substitution is that when two things are equal, you can use them interchangeably. They become synonyms for each other. So find one way of writing one thing as a combination of the others. Sometimes it'll be given to you, and sometimes you're going to have to solve for it. But in either way, you can do substitution. So go ahead and do the homework, and I'll see you in class.